Hello, this is Dr. Anthony Saras, academic rheumatologist from the University of Oxford, reporting for EULAR TV. I'm excited today to have with us Dr. Michelle Kahlenberg, who is a professor of internal medicine and dermatology at the University of Michigan and vice chair of the basic and translational research in the Department of Internal Medicine, the same university. So, Dr. Kahlenberg, nice to meet you.
Thank you.
So, would you like to tell us more about your presentation on the single-cell omics at this year's conference?
Yes, thank you. I am very excited to discuss some of the newest updates that are coming regarding using this type of technology. And I think it's very exciting because it's allowing us to actually study human tissue at micro detail. And I think some of the important themes that are emerging as we see a rapid rise in the use of this technology in lupus in particular is that the myeloid cell populations really come out as important in not only experiencing interferon signatures, but also correlating with disease activity. And the other thing that we see as a theme is that there is increase in cytotoxic T cells, particularly CD8 T cells, that are coming out in many of the different organs. But I think the other important thing that we are getting out of this information is that not every organ is the same. And so because you have active lupus in the skin, for instance, the cells that are there and the activation of those cells might actually be different than what we see in other organs. And that might explain some of the heterogeneity that we see in lupus patients where we can treat one manifestation of the disease, but something else won't respond to the same therapy. So I think that technology is really helping us to understand why patients look different and don't always respond to the same medications.
Yeah, I think this is an excellent topic, and we can see in such a heterogeneous disease such as systemic lupus erythematosus, there are different chemokine network, cytokine networks, cellular pathways, molecular signatures that drive inflammation in different ways. So for years we have assumed that inflammatory process in the kidney or the skin may be driven by the same patterns, but actually this may be wrong. So how do you think that these new technologies will solve that problem?
So I think twofold. One is they're telling us who the players are, so we can look and see specifically what different types of cells are in each organ. So I think that's very exciting. Using spatial technologies, we can also start to understand which cells are located next to each other so that we can figure out who the interactors are. And then I think what we're starting to see now is people are using these single-cell technologies in a longitudinal fashion to help us better understand treatment response. So that if we monitor the cell populations before and after a treatment, we might be able to find out predictors of who will respond and who won't by looking at individual cell populations. And using technologies like bulk RNA-seq, that might not be at enough detail of scale that we are able to actually find out those fine details that predict treatment response.
So, Professor Kahlenberg, last year you published an exceptional paper in Science Translational Medicine studying skin biopsies from cutaneous lupus using spatial transcriptomics. So would you like to highlight the findings of your research and how this can help decipher new pathways in lupus pathogenesis?
Yes, thank you. So I think our research has pointed to a few important things. One is that the actual tissue of the organs themselves is not normal. So in the skin, for instance, we find that keratinocytes and fibroblasts have activation signatures and are making cytokines and chemokines even when there's no rash present. So in that paper, we sampled both non-lesional and lesional or rash tissue. And so what we find is that the non-lesional skin is actually abnormal, and your research also has pointed to that as well. And I think that's really important because it makes a big impact on how we think about prevention and the importance of sunscreen and the role of the tissue itself in sort of educating immune cells as they migrate through the tissue. And then we actually showed in that paper that we could see that circulating cells undergo a major transformation when they enter the tissue to become much more pro-inflammatory than they are when they're in the circulation. And so I think that also points to us that studying the tissues is actually really important to understand the disease, because sometimes what you can find in the blood is not nearly as robust as what you find in the tissue. And so sampling tissues and understanding tissues is really important.
Absolutely. And I would like to highlight that arthritis research has done miracles in the past decade, and they have focused on early prevention, early stratification of at-risk populations, and I think the lupus community is still behind. So do you think that will change in the next decade?
I hope so. I think, it's a little disappointing that the Plaquenil trials haven't come out yet, but we'd all like to know whether Plaquenil actually can work as a prevention for lupus. And I think, for now, when we see somebody who doesn't need treatment, we kind of just watch them and wait to see what happens. And I think knowing specifically who's at highest risk and ways to intervene before they get sick, I think will be very important. So I do hope in the next 10 years that we'll at least know whether some of our meds that we like to think help prevent lupus can do that, and then hopefully find other ways that we can also prevent it as well.
Thank you, Professor Kahlenberg.
Yeah.
And before I let you go, would you like to make a comment for your research group and any exciting ideas for the future?
Oh, sure. Well, first, I'd like to thank my research team because they're amazing. But we're very interested in several different new pathways in lupus skin, particularly. One is mitochondrial activation. We found some very interesting data that will hopefully be out in the next year. Maybe at the ACR meeting, we'll have an abstract looking at the dysfunction of mitochondria in lupus skin, and also looking at hippo pathway signaling and how that might be regulating different interferon pathways. So, to be continued.
Thank you, Professor Kahlenberg. Many thanks for sharing your expertise here with us at EULAR 2023. Thank you very much.
Thank you.